one. Oh, we're up here to adding. All right? Remember this the example where we did in class, the example we did where we were doing Turing machines. And the Turing machine has multiple tapes. And so it would read these characters. It would remember it would have outputted already the answers here, and it knows the carry. And then he adds these two in the carry to get the new number, the new carry, and it moves along. Right? People remember that example? Well, this is just saying, suppose the tape alphabet gives you two numbers at the same time. Right? It gives you the ith digit of x and the ith digit of y at the same time. So you're receiving the input in the right order. Right? And then what do you need to compute? You need to say, well, what I remember the carry. And then I get this new x and y, and I add the two together in my finite state automata, and somehow I spew out the answer. So we have to add to this machine that the DFA can output things, right? Because it can't remember the answer. But it can get this x, it can remember the carry, it can get the x and the y from the next digit, it can compute what the next digit is, it can spew it out, and it can remember the next carry, so it can bring in the next x and y.
So when you just say it has an output, but it still can't write to its tape as output, right?
Yeah. Yeah. Here's the code again. Here, can you read that? Is that too small? Here we're just defining the machine. The machine's going to have a carry, has two states, right? Because the carry, even if we're doing addition over decimals, right? It doesn't matter what the base is. The carry is only going to be 0, 1, right? So we remember the carry, start the carry as 0, and then what does it say? I know what the carry is, and I get what character do I read? I read the next x, the next y. What do? I compute what the next carry is, and here I'm going to just say I output something, and it goes into the output stream. Right? Sometimes when they write an edge, we say, I'm in this state, I'm reading the character 0, then they put here, I say hi, and then I go over here. So this says, this is state 1 and this is state 2. We're saying, if I'm in state 1 and I see a 0, then I go into state 2, and as I go, I say hi to the world. Right? And that gives us a stream of output. People kind of buy that? How do you use it? Well, in this case, we're outputting the sum. Maybe the output is, I'm in this state where all I need is one more quarter. What comes is a quarter. And I now go into the state that says, and then what I output is a Coke. And I go in the state that says, if you want another Coke, you got to give me more money. Right?
Basically, the DFA can't remember anything from previous states, so that it has the carry on the state that it's on, and then repeats whatever.
Well, it's moving to a different state, yeah. But it can't remember the answers. So as it knows answers, it has to spew them out. So the nature of it, the problem is that the input has to come in the right order. The output's going to get spewed out in the right order. A Turing machine could look at the input in different orders and produce the output in different orders. A DFA has to do them in order. Everybody, any good? So here's another example, and we won't spend too much time on it, but